Hello everybody and welcome to exercise 2 on page 28 of the workbook. And here's another exercise dealing with the average value of a function. Now let's work through this problem step by step here. So they're giving us a function f of x equals 4 minus x squared. And we're interested in it just on the interval from 0 to 2. Okay, and part A is reasonably straightforward. It would just like us to calculate the average value of f on the interval from 0 to 2. So there, all we really need to do is to use the formula for the average value, okay? And if you sneak a peek a couple of pages ago, and actually I think it's on the last page, you'll see 1 over b minus a. Remember that the b and the a are just the names for the endpoints of our interval, times the integral from a to b, so of 4 minus x squared. Okay, if we do this calculation, we should get the average value. So let's do that and just see what we end up with here. Okay, so we need an antiderivative for 4 minus x squared. That's going to give us 4x minus x cubed over 3. Okay, we're going to evaluate that between 2 and 0. So that's going to give us, let's see, if we plug in 2 for our x's, we're going to get 4 times 2 is 8. Minus 2 cubed is 8 over 3. There's our upper limit. And if you plug 0 in for x, you're going to get zeros for both terms for the lower limit. Okay, do a little arithmetic here. And the first 8 we can write as 24 over 3, just to get a common denominator, minus 8 over 3. Okay, let's see. That's going to give us a half times 24 minus 8 is 16 over 3, okay, which is 16 over 6, and if you reduce that, that reduces down to 8 over 3. Okay, so if we've done everything right, that should be our average value. Okay, on to part B then here. Okay, now this is a little bit more interesting of a question. We haven't seen one like this yet. It would like us to find a number c between 0 and 2 so that the average value is equal to the value of our function at that point. Okay, let's first algebraically find that c, and then maybe we can talk a little bit about the significance of it. Okay, so just thinking strictly algebraically here, we know what the average value is. We just calculated that in part A, so the left-hand side of our equation is just 8/3. Okay, what is the right-hand side? Well, f of c is just saying take the number c and substitute it into our function. Okay, so if f of x is 4 minus x squared, then f of c is just 4 minus c squared. Okay, and so really, they're just asking us to solve this equation for c. So let's do that. If we add c squared to both sides, okay, we're going to get that, and then maybe subtract 8/3 from both sides. Okay, and if you take 4 minus 8/3, okay, get a common denominator, that's 12/3 minus 8/3, that's going to be 4/3. And then the question is, how do we solve this equation for c? We've got c squared equals 4/3. All we really need to do is to take the square root of both sides. And when you do that, there are going to be two possibilities. We might get the plus or the minus square root of 4/3, okay, which we could rewrite as plus or minus 2 over root 3 because the square root of the top, the square root of 4, is just 2. Okay, so that's actually two values for c, but are both of those c values valid? Okay, remember that they wanted c to be between 0 and 2. One of those c values is negative, and so it's not going to be between 0 and 2, which means that we can actually throw away the negative one. Okay, so the only c value that's relevant to our problem is the positive square root. 2 over the square root of 3. There's our answer. Okay, now what is the significance of this number that we just found? Let's think about that for a minute. Okay, we just found a number that if we substitute it into our function, it's going to give us the average value of our function. I can give you maybe an example from real life that might illustrate that principle. let's say that you get into your car and you drive from San Francisco to LA, okay? And somebody keeps track of how fast you're going the entire way and determines that your average speed in driving from San Francisco to LA is 70 miles per hour. Okay, well, what does that mean? It doesn't necessarily mean that you drove 70 miles an hour the entire trip. Maybe you did, okay? But it may very well be that your speed was above 70 miles per hour some of the time and below 70 some of the time. But what we could say is that because 70 miles per hour is your average speed, there's got to be at least one time where you are driving 70 miles per hour in that trip. That's what this C value is like that we just calculated here. There's got to be at least one time in the interval between 0 and 2 where our function agrees with its average value. Okay. And lastly, there's one other part to this problem. Okay, they'd like us to sketch a graph of f in a rectangle whose width is 2 and whose area is the same as the area under the graph of f. What is the height of your rectangle? Okay, well, this is kind of a mysterious sounding question at first, but it's going to give us sort of a graphical interpretation of what average value is telling us. Okay, so I want to start by just making an observation from part A here. Okay, in part A, we calculated the average value, and our calculation looked like this. I'm literally just recopying what we did in part A. Okay, we took 1/2 times the integral from 0 to 2 of 4 minus x squared dx, and we got our average value to be 8/3. Okay, you can look back at part A and see that that's what we did. Okay, what I'm going to do is to take that equation and multiply both sides by 2. We can do that as long as we do the same thing to both sides. And what that's going to do is to cancel the 2 out in the bottom here and to just give us the integral on the left-hand side. And over on the right-hand side, we're going to get 8/3 times 2. I'm going to deliberately leave that unsimplified. Okay, well, it turns out that we can draw a nice picture that kind of illustrates this second equation. So first of all, notice that what's on the left side of the equation is the integral of our function. That just represents area under the curve. Okay, and in fact, if you graph 4 minus x squared, it's just a parabola, kind of part of an upside down shaped parabola. It kind of looks like that. Okay, so you can think of the left-hand side of the equation as just being the area under the curve. Okay, what the problem is asking us to do is to draw a rectangle that has that same area. Okay, and the right-hand side of our equation suggests how we might do it. Think of the 8/3 as being the height that we want, and the 2 as being the width that we want. Okay, if we draw a rectangle that has a width of 2 and a height of 8/3, what we'll discover, okay, this number happens to be 2 over here, we're going to get a rectangle that looks like this. Okay, notice that it has a height of 8/3 and a width of 2. Okay, so they ask us what's the height of our rectangle. Well, we can see it from our picture. The height is 8/3, and what's special about that 8/3? That 8/3 was the average value of our function. Okay, and so here's what we've discovered. It's kind of an interesting geometric fact that the average value of a function is special in the sense that if you draw a rectangle like this, whose height is equal to the average value, the area of that rectangle matches the area under your curve. Okay, and so I'm going to write that just as a comment at the end of this. The shaded area of the rectangle equals the area under our curve from 0 to 2. That's a graphical way to think about the average value of a function in terms of areas.